Today we're going to be talking about direct variation. Now this is related because we're still going to be looking at slope, or we're going to be calling it our constant. Very similar to what we were doing earlier, but kind of leading into what we're going to be doing with a linear equation. So when we talk about a direct variation, this is what makes something a direct variation. If the ratio of two variables is constant. So that means if your x is 3, your y is 6. Your x would be 4, your y is 8. There's a direct variation, we're multiplying 2 to every x value. Or we can multiply a fraction, or a decimal, or anything like that. The basic form, you can look at it in two different ways. The first way is here. Y equals k times x. The second way is y over x equals k. Both of them are the exact same equation. How we go from here to here is just dividing both sides by x. That brings the x over here and it cancels on the right. Now when we're looking at this formula, and again remember, oops, forgot the y in there. Whenever we have equations, x and y are usually going to be your variables. They're always going to be in the equation. The k is the constant. We need to have a number for that constant, whether it's an integer, whether it's a fraction, whether it's a decimal. All right? That should be a number here. So when we're all said and done, our equation might look like y equals 2/3 x, or 2/3 times x. That's what we're looking to do. So we would read this, y varies directly with x. That's how we would explain that. Y varies directly with x. Or our math score varies directly with our attendance. Or the amount of pay received is directly related with how many hours you put in, if you had a job. So in your notes it says, so the next thing we're going to be looking at is identifying if something is a direct variation. Now this is very easy if you remember this part. If you notice from these things, there's no addition or subtraction. It's either multiplication or division. That constitutes a direct variation. Right? There is no addition or subtraction. Once there's addition and subtraction, when we get either the y by itself or the k by itself like this, then it becomes not direct variation. So eventually we're going to be graphing these, and you're going to see that every one of these lines goes through the origin on our graph. So if we're looking at the first few problems, we have 7y equals 2x. Now we want to try to put it in one of these forms. So for letter A here, 7y equals 2x. Well, if I look at this, none of these indicate a number by the y value. It's always by itself. So in order to get rid of this, to make it y equals, trying to get it in this form, we divide both sides by 7, and we end up with y equals 2/7 x, or 2/7 times x. In this case, the constant is 2/7, and it's multiplying by x. No addition or subtraction, so this is a direct variation. Letter B. We have 3x plus 4y equals 8. Trying to get y by itself. So this is going back earlier in the year, trying to get the y value by itself. We start by adding opposites. We're left with 4y equals negative 3x plus 8. We divide by 4 to everything. And we end up with y equals negative 4/3 x plus 2. Now I see addition here. I see the y by itself in this form, but I see addition here. Automatically, not direct variation. Automatically, there's addition there. Now we're going to jump over to letter C, which is 4x plus 5y equals 0. Right now I see addition in there. But again, I want to get the y by itself in this form here. So I'm going to add negative 4x. Divide by 5. And we end up with y equals negative 4/5 x as our answer. Once I transformed it into y equals, no more addition or subtraction. So again, letter C, this is direct variation. This one is. If we graph this out, you'll see that it will go right through the origin with the points 0, 0. Now how can we apply this? So if we look at this problem, the next set of problems where it says writing a direct variation. It says, suppose x or y varies directly with x, which means we're using this equation. And y equals 35 when x equals 5. Now remember I said that we need to get a number for the k value. We want to leave x and y in our equation. So we need to use this equation. We want to substitute the 35 in for the y, and this is letter A. We don't know what k is, we need to find it, and it's times 5. We need to solve for k. Here we divide both sides by 5, and we get 7 equals k. So our equation is y equals 7x. Now if we put, our next part of the problem says, what is the value of y when x equals 9? I'm going to substitute this this x value in as 9. Put it right here. We can easily multiply that out. 7 times 9 is 63. I'm going to leave letter B up to you to finish. So make sure you finish B the same way we did with letter A. Letter C is a word problem. It says that it's being a direct variation with the weight of Mars and the weight of Earth. So we have Mars varies directly with the weight of Earth. So it says the weights of the science instruments on board the Phoenix Mars lander on Earth is 130 pounds. On Mars, it only weighs 50 pounds. What is the equation that relates the weight of Earth to the weight of Mars? So we need to solve for k. And k equals, and I get 5/13. I'm just going to reduce that. Leave it as a fraction. So now my equation would be y equals 5/13 x. It says if a man weighs 250 pounds on Earth, so we want to put the 250 for the x. I don't know how much he weighs when he's on Mars. So we go 5 divided by 13, and then times 250. And we get 96.15 pounds. So again, not quite as much on Mars as he is here on Earth. Now, graphing a direct variation. Let's say, let's continue with the notes. So we have this equation, y equals negative 2x. We want to graph this. Now I know it's a direct variation because again, there's no addition or subtraction. I'm going to start with the chart. Maybe I start with -5, -2, 0, and 4. Just picking random numbers. I'm always going to pick 0. 0 is a great number because it's easy to multiply. So when we plug this in, -2 times -5, we get 10. -2 times -2 is 4. -2 times 0 is 0. Remember, it's got to go through 0. 0, comma 0. And then -2 times 4 is -8. If we were to graph this, I'll do this on the board. Again, when I plot these points, this is where they plot. They will always make a line right through the origin. Just like that. Just like we plotted in the last section we did, this is our slope. Our slope is -2. It's our rate of change. It's going down. Remember, negative slope goes down to the right. So if we're looking to graph these, we know it's going to the origin every time. That's something to remember. If it's negative, it's going to go down. It's going to go down 2 and over 1 each time. If we were drawing our little steps, making our triangles, then it would look like that. Now the last part of the notes is identifying if a given chart is a direct variation. So we're going to look at the first one and the last one. We have -6, 9, 1, -1.5, and 8, -12. This is the bottom of page 2 of the notes. Now in order to identify this, remember this equation when we had y divided by x equals k? We need to know if our k values are all the same. So we divide 9 divided by -6, we get -1.5. -1.5 divided by 1, just like we are here, y divided by x. We will see that all of these equal -1.5. This means this is a constant ratio of 1.5. So the first one is direct. The last one, and we have to make sure every situation works. In the second one, -2, 1, 3, 6, 8, 11. If I go 1 divided by -2, I get -0.5. I go 6 divided by 3, I get 2. Automatically, once these numbers do not match up, this is not direct. And we can identify it that way. So you have to make sure you divide every one out to make sure that it works. See you next time.